Okay, hey everyone. So you may have remembered from a previous session, we talked about programming in ATM. And if you weren't physically here in the room, then you didn't have a chance to program it. And actually, we should have probably used a flowchart to sort of draw out the program before we actually dived in to programming. Because one of the things that we realized when we were doing it on the board was that there were lots of things nested inside of other things that we missed, and so we had to like sort of erase and stick things in between in the middle of lines because we didn't realize that we needed it. But if we had done a flowchart beforehand, that wouldn't have been a problem. And so if you don't remember what a flowchart is, it looks sort of like this, and that we should pretty much be able to do everything using these four. Let me give you a pointer. These four symbols, and then connecting them with an arrow connector. And so let's do that. So here's the specification. Here's the symbols that we have to work with. And so the first thing that we know that we need to do is we need to take input from the user on what they want to do. And so that's going to be one of these. So I'm just going to be lazy and just copy and paste everything. So we have our input output, and so we're going to say that this is the input of their option. And actually, now that we think about it, maybe you want to give the user these options. So maybe we're going to have an output of the menu. So we go from the menu to taking the options, and we're going to connect those. And we're going to connect those with an arrow, and the arrow is going to go this direction. Okay. And so then the user selects what they want to do. And based on what they want to do, we're going to take different actions. So that sounds like a decision diamond or triangle. And so the option and then from the option, we're going to go into these different modes. And so one of them is going to be this exit condition, which is how we're going to get out of here. So we're going to need a terminator for that. So we can just stick that down here, and we can say exit. And maybe let's make a terminator that's the beginning. Somebody approached the ATM and they inserted the card. So and so we know that from the card inserted, that from exit, it's actually going to be a loop. No, I'm sort of jumping around, but that's sort of how this goes. So from exit to a card. Let's see. There we go. Curve connector. There we go. And it goes this way. So we know that from exit, the terminator is going to go to card inserted, and that one of the options from input output is going to be so take input, and then you're gonna take some paths. So one of the options is that the user exits, and the user exits. Let's say that the menu that the input that is going to be typed in is going to be 1 through 4. So 4 is out. 4 is this exit here. 1 is withdrawal and whatnot. And so then let's label that as well. So we know that that's going to be a 4. Okay, so from the option, so user inserts a card. We display the menu as output, and we take input, the number 1 through 4, because maybe they said 1 is withdrawal and 4 is exit. And then from there, we go into making the decision of what to do next. If the input was 4, then they exit. Then it exits, and then we sit in this la-la land waiting for a card. And so maybe we might label that. So in this la-la land, we're waiting for a card to be inserted, and the moment it's inserted, so that might actually be a process that's in here, right? Okay. Great. So now, oops, we need the process back. And what else am I missing? The input output. Okay, great. So now let's handle the other options. And so maybe we'll take up this space over here. Also, one of the things that we mentioned in class is when we're dealing with money, what is a better thing than an integer to use for money balance? Right, they're decimal points, and they're 2 decimal points. So a double, perhaps. Doubles are much better for money balances than an integer. If you're dealing in, the ATM might only distribute things in integers. Like most ATMs don't give you change or whatnot, but they should be still aware of how much change you have exactly. Okay, cool. So now so that was option 4. So now let's do option 3. So option 3 is simply going to just be an output of you're going to print out the balance. And so now the question is, what happens after you print out the balance on a normal ATM? Well, on a normal ATM, you start over again. You go back to the menu. Right, the menu is going to give you all those options again. I don't think that's B-A-L-A-N-C. There we go. Sorry about my spelling; it's always atrocious. Yeah. So, and this was option 3, right? And so what kind of structure do you think that we need to put this in? Right, now we see things coming all the way up back to the top. This whole thing becomes a loop. And we're always going to be asking the user for stuff. So what kind of loop do you think we should be using? This is a perfect situation for us to be using a do while loop, because we always are going to run once, even if the user want to put in the card and they want to exit. They still have to do that. So do while is really good because that allows us to always run at least once, and then the user can exit, and then it starts all over again. And that as long as they don't enter in the 4, they don't go to this waiting to card inserted, which is the exit. And in the case of your program, we might just right here at exit, we might actually just exit, and then we might not do this part. But in general, for an ATM, you probably want to be able to vend out money to just more than one person. You'd be pretty pissed off if you bought a microwave. The microwave worked exactly once. So there is this structure of having this infinite loop, but we're going to actually ignore all of this. But I just wanted to put it there so that it helped reinforce how an actual real ATM works. So actually, let's just get rid of that. Okay. So the next, let's go to number 2, deposit. So deposit the machine. So imagine that maybe we just have a way of asking the machine to consume the money, and so that's going to be a process. So somebody is going to say deposit, and there's going to be a process of and this could be input output. But for this case, we're going to consider input output as presses on the keypad, like 1 and 4, and then output is going to be stuff that we print out to the screen. Versus taking their money or giving them money is a process that we're going to ask the machine to do. So yeah. And so in the case of a deposit, right, so we go to deposit, and this was option 2, right? And most of the time on ATMs, when a deposit has happened, you print out their balance. And so from here, we might go to print balance, and then it goes back to the main menu. But let's be jerks, and let's just take their money and not tell them how much money they have. Let's just go back to the main menu. Because if they want to know how much money they had, you might as well print their balance. So option 2, we take their money and we go back to the main menu. Okay, so let's handle withdrawal now. So withdrawal is another process. So withdrawal is a little bit different because they need to specify how much money they want. So, oh, and just triggered the lights in here. So we're going to ask them how much money they want. And then from there, let's make that a little longer. And then from there, we need to make a decision on whether or not they actually have that much money. And then if they do, we give it to them. And if they don't, we need to display an error. I'm going to scoot everything over. Right? So we have our decision. Or maybe input is less than balance. Or equal to, right? And then if they do, then we give them their money. And if they don't, we're going to print out an error. So that's output. Great. So now let's connect all these together. So if the option is withdrawal, we prompt them, we either dispense the money or we hit an error. So this is true. And then this over here is going to be false. And then after this is done, we need to go back to the main menu. Cool. So I think we have everything. We start it up. We print out the main menu. We take in the input. We go into the decision diamond that splits off into these four. Oh, got to label this one. Goes out to these four splits. If they want to exit, then this is how we exit out of the loop. So maybe this exit, this 4, is our condition for our do while loop. And then we have option 3. We print out, we have the output of the balance, and we go back to the main menu. 2, we deposit, we take their money. And we would also, increment whatever money we took, we would add it to balance. And then if they selected 1, then we would ask them how much money they want, and then if they actually have that in their account, then we give them their money. If they don't, we throw an error. We print out. We have the output of an error, and we go back to the main menu. Cool. So just having a visual representation can be really helpful because you can now give this to somebody. So maybe you're doing pair programming and you print this out and you have it with you. You can help use this to point to different parts of the program, make sure that you actually have code that corresponds to every case that's here. Also, for me personally, there have been many times when I've made flowcharts and then been able to hand the flowcharts off to somebody else that they could then go and program it. So there are a lot of organizational things where you make a flowchart and then other people are following what the flowchart set tells them to do, and that can be very useful because suddenly now you don't need to be around. You can go off and work on cooler projects. Great. Okay. So let's program it. Why not? What week is it? Just for funsies, let's say is it week 4 or week 5? Oh, it's 05. Okay. Just make sure I don't have anything lying around. Okay, cool. So let's grab my my starter code, blank CPP, and we're going to call this atm.cpp. Great. Okay. So let's leave our comments. So let's make sure that we're in a working state. Great. All right. Okay. Okay, so let's go back to looking at the flow chart. So remember how we talked, we see this inherent looping that's occurring in our flow chart. Actually, let's start to merge that all up. And so because we see all of these things keep going back to menu, maybe we're going to print out the menu. So let's do that, but we know that we need a do while loop. So do while, and do you remember what the condition was? Right, it's probably going to be this guy. So we have our int input, and then maybe we set it to something that's going to be invalid, and that, because we know that somewhere in here we're gonna stomp over the top of it, while input is not equal to 4. So let's try this out. Right, we're just going to keep taking input until the user inputs. So, and then let's also, just a little bit of advice. Before your program exits, it's always good to print out an end line. Let me show you what happens when you don't. So 1, 2, 3, 4. In this environment, it printed out this weird thing. But most of the time, let me show you in Bash. This is the shell that you're going to be working with. 1, 2, 3, 4. Notice how your prompt, the goodbye and your prompt are on the same line. This is considered bad. If you write a program that does this, this is heavily frowned upon because it looks bad. So always make sure that at the end of your program that you print out the new line. Even if it's just a cout endl at the bottom. Make sure to print out that new line before you exit your program. Okay, great. So let's just rerun it. So 1, 2, 2, 2, hello, 2, 4. And notice that hello messed us up because now we actually can't escape. 1, 2, 3, 4. Right. So when the user gives a bad input, it's going to mess you up a little bit. So just be aware of that. We'll learn later how to ignore that or how to throw an error. Okay, cool. So we've got our do while loop, takes an input, and it keeps going. And so now we're here. Let's look back at our flowchart. So we've got our. So actually, let's print out the menu. Let's be nice to the user and let them know that we expect something from them. Cout, enter 1 for withdrawal. Why is this not? Huh. 2 for deposit. 3 balance and 4 to exit. Great. So we've got our menu. Actually, instead of new lines, let's just make these commas. This line's getting a little long. Typically, when a line exceeds 80 characters, you should start thinking about making it into separate lines. For some reason, I don't have my my character count, so this is pretty close. Okay, cool. So now we've actually told the user, right? We've printed out the menu. We take in our input, and now we have to make this decision. And so the structure that we're going to be using in this class is if-else. There are other different structures, but for the most part, in this course, we're going to be using if-elses. There's a thing called case switch, which I would not recommend using in this class. Maybe in the future, but one of the issues is that it has a keyword called break that it uses in the middle of it, and break is very dangerous if you misplace it, and it can cause your program to behave in a way that's very hard to figure out and fix. That's why I sort of try to recommend against using case switches because of that keyword. It makes it hard to trace a program, especially when I make a flowchart like this. The break, if it's triggered by some weird condition, then that means that like all of these operations have like a route back to somewhere, and that might be even a route back to exiting, and not using the normal exiting process, which can be really bad if your program has to set lots of things up. If the program just ends abruptly and it didn't put everything back properly, maybe you've corrupted some files now. So it's really dangerous. So we're essentially just going to be using if and else ifs and elses. So let's do that. So what's the first condition that we're going to do? And so I always think of this, think of it as like a filtering process of what do we think the user is going to do the most, and putting that up at the top. And that's good for the computer, because then it doesn't have to go through all of these different comparisons to make sure. In this case, we only have 4 options, but this is exactly how a normal ATM is going to be programmed, that withdrawal is the most common thing that is done on an ATM. And so that's going to be up at the top. And so we're going to check whether or not input is withdrawal, which withdrawal is 1. And so then withdrawal, and then we're going to have our else ifs. And let's just follow this order, because this tends to be the use of an ATM. Okay, great. So this is going to be input equals to 2. And in this case, we don't necessarily need to have an else for the exit, because the moment we hit right here, we're just going to exit. If you wanted to print out an additional message or something like, hey, you've selected exit, you could do that. But pretty much this will only happen, this printout here will only happen when input is equal to 4. Otherwise, this could just be like an else and then, you know, goodbye or whatever. You don't need, you never need to do an else if and then make sure that they've typed it in. Also, something that we might make sure that we do is we might force the user to enter in valid input. And so let's finish this part, and then let's make sure, and then let's add that part afterwards. So first the withdrawal part. So with the withdrawal part, we're going to, oh, and we forgot our double. Balance. And right. And so let's start out with $1,000. You know, we're rich students, right? Great. So the first thing that we probably need to do is make sure that they actually have the money. And if they don't have the money, we're gonna see out not enough monies, and then that's going to cause the loop to start over again, and then our condition is going to be oh, and we need to take in amount, so double amount. And actually in this case, maybe we only want them to take in, they only request things as integers. So int amount, and then we're going to initialize it to 0. We're going to say cn amount, and then if amount, or what did I say? Oh, input balance. So if it's smaller than or equal to balance, then we're going to actually do the, you know, give them their money. And so maybe there's a class called ATM that we would call, so it's be like something like ATM dot dispense, and then the amount. But we don't have that ATM class right now written already, so so I'm just going to leave that there, and I'm just going to say cout. Here's your amount, and then a new line. Cool. Okay, so that's the first one. So then the second one is the deposit, and so this essentially we would be calling, we would just be calling the ATM ATM dot deposit cash, and that this we would do like a plus equals this to balance. But we don't have that ATM class, so we're just going to say cn, oops, and these are all separate amounts, and I'm going to make this a double in case it's a check or something. Also, we've been typing a lot. Whenever we've been typing a lot, we should make sure that our program still compiles. And it compiles, must be good. So let's withdraw some money. Let's get our $10. We got our $10. Now we want to, oh, whoops, I missed the deposit. So see the number for deposit's missing. 2 for deposit, 3 for balance. Okay, great. So this is just going to be cout balance. Maybe we want to label it. Okay. Cool. So there we go. So now we should have a somewhat working program. So let's withdraw some money. Let's take our 90 bucks. Got our 90 bucks. Let's take a look at our balance. Oh, would you look at that? Our balance was not affected. Wonder why? It's because we never subtracted it from our balance, right? We ask them how much money they have, so as long as they keep asking for $1,000, we're never going to take it away. So inside of right here, we're going to do it. Because what happens if right here I said balance minus equals amount? What's going to happen here is if they ask for a ton of money, maybe they asked for $2,000, then we would subtract their account by $2,000, and then we would throw this error. We'd say, like, oh, that's not enough money. And when they go to check their balance again, it would be negative $1,000. So they just lost $2,000. So we want to make sure that when we actually go to take their money, that after we've taken the money out of their account, that we've actually given them that much money. Yeah, we've actually given them that money. This is a common mistake that a lot of programmers make. They don't think about these edge cases when maybe they didn't have enough money and you deducted it from their account, but then you forgot to give them the money. Also, you might have an if in here to make sure that the ATM actually has enough money to be able to give it to the user, and that after they've given the money to the user, that no errors have occurred. So for example, if the machine broke down in the middle of trying to give the person the money, and it didn't actually give them the money, that you don't charge it to their account. So you got to make sure, because otherwise you just took a ton of money from somebody and you never dispensed it from to them. Okay, cool. So let's make sure that this worked. So we're going to withdraw some money. Let's take our $900, and then let's take a look at our balance. All right, that's good. So we started with 1,000. We took 900. We have 100 left. Let's deposit some money. So let's deposit 50 bucks, and then let's take a look at our balance. All right, and then let's get out of here. All right, so there we go. So now let's make sure that the input that was given is valid input. And there are more clever ways than this that we'll learn about later in class. But I'm just going to show you the really basic one. Sorry, skateboarder. Okay. So what we're going to do is we're going to do a do while inside of a do while. So while. So we're going to say while input is smaller than or equal to, and so we're going to pick the 4, right? So either the user hits 4, or well, actually it would be and input is going to be greater than or equal to 1. So both of these have to be true. That it's either 4 or less, or it's 1 or more. So if you look at that on the number line, those both intersect hopefully. So what's going to happen here if they enter in something that's not these values? You're just going to run the loop again. And most of the time, I like to group these up so that it's a lot more clear what's happening. Because when these get really, really long, it's really hard to read. So we've now grouped, this is going to evaluate, and if this is true and this is true, then the whole expression is going to be true. Also, something that happens that you can exploit, and it's not gonna matter too much in this class this semester, but it's going to matter a great deal in future classes. You can check something if something like exists before you check its value, and this and it's going to check this first and then this. And if it's an and, if this is false, it doesn't bother to look at this part. And so you can do clever things like right here, you could say like, hey, does this thing exist, or does this thing have a value? And then here you could be like, okay, well, what is that actual value? So again, that's not going to matter that much this semester, but it will matter a lot next semester. Cool. So let's try this. Let's give this for a ride. So let's compile it. Oh, what did I mess up? Some curly braces somewhere. Ah, I forgot my closing for my do. Okay. All right, compiles must be good. Okay. So let's withdraw some money. Let's, oh, maybe I messed something up. So that error is considered, is either a runtime error or a logic error. That as a programmer, I messed up my greater than less than symbols. So let's look at this again. Ah, right. So the condition that I wrote here, this is when I want to exit the loop. This isn't when I want to escape from the loop. So what I can easily do is I could easily just stick a not in front, and actually the not would be in front of the whole thing, right? Or I could just change the conditions of the loop. So I think it's called De Morgan's law. Essentially, I'm just going to invert these. And then I make it this an or. So if they entered something that's bigger than 4, or they entered in something that was smaller than 1, we're going to keep them in the loop. Compiles must be good. Okay, let's try this again. So 0. No, -1. 900. Okay, looks okay. Let's see if a normal one works. Okay, we entered in a 1. We're going to ask, maybe we should have prompted the user how much money they want, right? So we're going to take $20, and then it gives us our $20. Now let's look at the balance. So looks good. We started with 1,000. We're at 980. Let's deposit some money. We're going to deposit $50, and let's make sure we've got the $50, and then that looks good. And let's exit. Cool, cool. So there you have it. We got our code for an ATM. And so documentation is really important. Notice how, at the end of all these curly braces, I commented what they belong to. And then up here, I have these blocks. And so now, there we go. So yeah, documentation is really important. That you leave notes behind of exactly where you left off, if anything, if there's input that breaks your program, and whatnot. Or in this case, right, we left documentation on how to, like if this was a future ATM, how we would actually call it. And later we'll actually write this class probably. in a supplemental instruction session. Okay, cool. So there you go. We made our flowchart, did the program, all good. And I'll throw that program up on GitHub when I have a chance. Yeah, so there you have it. Let me know if you have any questions. Feel free to email me. Let me pull up, yeah. And actually, let me pull up my GitHub too, just so you have. I should really be putting this link at the bottom of everything. Yeah, so get this address here is where I post the lectures, and then it also where I post all of the all the slides and whatnot. Cool. Well, see you on the flip side.